This is a short video to demonstrate people who are taking the standard mathematics course in Year 12 how to create a dot plot using Microsoft Excel, and then also find the correlation coefficient and the line of best fit and its equation using the same software. We are using data that comes from Nelson's New Century Mathematics book, in particular exercise 501, page 161, question 7. I've assumed that you are able to type data into a spreadsheet. If you are unsure about this part of it, please let your teacher know. Once you've got the data from the spreadsheet typed up, or if you've downloaded the file directly, we can create a scatter plot to try and look for a relationship between two of the variables. In this case, I'm going to look for a relationship between age and waist. Because I need the relationship between both those things, the first thing I'll do is highlight all the data in the age section. Holding down the control button, I then highlight all the data in the waist section. Now that we've got the data highlighted, we can tell Microsoft Excel that we want a scatter plot from this data. At the top, click Insert. We're going to insert a chart, which is in this middle area, and we're going to insert a scatter chart as it says here. Click the scatter chart icon, then click the first scatter icon in the top row. It will add a chart that looks like this for you. To display the data better, I'm just going to make a couple of quick changes to the chart. First thing I'm going to do is add on axis titles so we can show which one is which. Our horizontal axis is the one by default that's at the top in the data we selected. The one at the top from the two bits of data we selected was age in years. The vertical axis shows the dependent variable, in this case waist size in centimeters. And I'm also going to quickly change the chart title to make it make sense. So this is showing how someone's waist has changed over time, or for different people what their waist was against their age. The scatterplot's got all the information on it now, but it's still not as easy to read as we would like, so I'm going to make two further changes. The first change is to add some grid lines to make it easier to read something that's not exactly on any of the vertical or horizontal lines. Click the Add Chart element at the right hand side. We're going to add some extra grid lines, so we scroll over to the right, click the black arrow, check the boxes for primary, minor, horizontal and vertical axes. However, it's still quite hard to get an idea of the strength of the relationship, although we can see quite easily that there's going to be a nice straight line forming there, because no one had any waists between 0 and 50, so actually a lot of our plot area is taken up with space that's not useful. So if you right click on the axis and click Format Axis, we can then decide our bounds here at the top, so the smallest number that it will show and the biggest number. Since we don't have anything below 50, let's set 50 as our minimum. That looks much better. We can see the relationship a lot more clearly. We can also do the same thing for the horizontal axis. Here we've got no one under the age of 4, but to leave a little bit of space, let's make the lower bound 3. And once again, it's a little bit easier to see. If all you were looking to do was to add the scatter plot, then this is enough information for you to add a scatter plot using technology. I'm now going to show you how to do the equation of the line of best fit, the least squares linear regression line, and also the correlation coefficient. To do that, we need to add something to the chart, so we're going to click the Add Chart elements at the top right. Both the correlation coefficient and the trend line, line of best fit, come under the category of trend line here. To get all the parts added, I'm going to left click the right black arrow and go to More Options. Microsoft Excel will default to adding a straight line as the line of best fit. You can see there are other options here, but they're not covered within the Mathematics Standard 2 syllabus, so we won't talk about them in detail. Instead, scroll down to the bottom and there are two handy checkboxes there for you. If you click the top one, it will display the equation on the chart. Here we have that y is equal to 1.6429x plus 45.714. We have to remember the context here. Y is the dependent variable. It's the one displayed on the vertical axis in this waist size. X is your independent variable, the one that's displayed on the horizontal axis, in this case age in years. So this formula is saying that your waist size in centimeters is equal to 1.6429 multiplied by your age plus 45.714. You could use this equation to numerically work out what someone's waist size should be given their age. For example, we don't have anyone with the age of 11 in here. We can read off the graph and see that it's going to be roughly 64 centimeters, but equally you could put in 1.6429 times by 11 plus 45.714 into a calculator, or an even Microsoft Excel spreadsheet on the left if you want, and that will give you a more accurate answer using the equation of the line of best fit. The other checkbox on the right hand side says display the r-squared value on the chart. This adds one of the things we need to know to help out the correlation coefficient. Here our r-squared value is 0.9787. However, it's important to remember that the correlation coefficient is r, not r-squared. So into your calculator, you need to type in the square root of 0.9787. It'll give you a value of 0.9893 to 4 decimal places. That is, hopefully you should know, a very, very strong positive correlation between those two things, suggesting that as your age goes up, your waist size is going to continue to increase, and the waist size will match its increase fairly closely to an even pattern as you get older. Of course, here we're looking at people between the ages of 4 and 17. Hopefully you should be thinking that the limitations of this model are once most people get to sort of 18 or 20, really they stop growing. Their waist size doesn't necessarily change very much unless something else happens like big changes in their diet. So that's one of the limitations of the model. This video then has shown you everything you need to know in order to use technology to complete the Mathematics Standard 2 syllabus in terms of bivariate data analysis. If you've got any questions, you can always ask your teachers in class and they'll be happy to help you.